We are doing a product rule with tables or with values being plugged in. So let's go ahead and see what they gave us. Well, we got f at 3 is equal to -1. F prime at 3 is equal to 0. They give us the function g sub x is equal to x cubed. And then we're asked to evaluate the derivative of f times g at x equals 3. So the derivative of f times g, and I'm starting to leave off the x's because it's so redundant that I think we're okay. We're more of getting the process here. We're respecting x. So it's the derivative of the first times the second plus the derivative, so we can see it, plus the derivative of the second times the first. That's how I remember it. I know the formula is a little bit different than what Khan gives you or you might see elsewhere, but this definitely works. And to me, it's easier to remember. So that means we need f and f prime at 3, check, check. We need g and g prime at 3. So we need to evaluate g. So g sub x, I'll put my x there when I'm actually doing it, is going to be the exponent goes out front. The exponent gets subtracted by 1 and leaves a 2. All right, now I'm plugging in 3 into here. So g sub 3 is equal to 3 cubed, which is equal to 3 times 3 is 9, times 3 is 27. And g prime of 3, plugging 3 into this one, is 3 times 3 squared, which is 9 times 3, which is also 27. Okay, so all we do is we just plug those into this function. So that means this is equal to, and I'll just write it up here to keep track, f prime g plus g prime f. All right, f prime is what? At 3 is 0 times g, I don't need it, but I'll write it, times g at 3 is 27, plus g prime at 3 is 27, plus our f function at 3, f function at 3 is equal to -1. This zeroes out, and we're left with -27. Okay. So things to remember, always rewrite your formula as you're practicing it. And then for this kind of problem, I would recommend just writing out all the components that you need. That way, when you're actually substituting in your variables and your values, you can just reference what those are, and it'll be a lot smoother. Next problem, let's see, a little bit different format. Okay, let g be a function such that g1 is equal to -2 and g prime of 1 is equal to 7. Okay, so they give us g. H is the square root of x. Let f be a function. Find f prime of 1. All right, so that means, what do we need? We need h prime and h both at 1. So I'd say h prime of x is equal to, note that h of x is equal to x to the 1/2. So a lot of these things I do in my head, so I just want to make sure you're seeing what's going on here. Exponent goes out front. If I subtract 1 from 1/2, that leaves -1/2. Okay. It's up to you if you want to flip it, and I might as well right here so we can see what's going on. 2's on the bottom. X goes on the bottom also. No more negative exponent. And this is the square root of x, so I don't have to write it as square root of x. I recognize 1/2 power is the same as square root of x. So when I calculate it, it should be fine. All right, so now I need h of 1. H of 1 is going to be the square root of 1, which is equal to 1. I also need h prime of 1. H prime of 1, plugging it in here, 1 over 2 times 1 to the 1/2, or square root of 1 is just 1. This is equal to 1/2. Now, our f prime of 1 is going to be our, in this case, the first derivative times the second plus the second derivative times the first. G prime at 1, G prime at 1 is 7 times H at 1. H at 1 is 1. H prime at 1 is 1/2 times G at 1. G at 1 is -2. Okay. Turns into 7 minus, that's 2 over 2, 1. Answer 6 is our final answer. All right. So the one thing that may be a little bit confusing is we're evaluating it at 1. So when I'm looking at my kind of foundation formula right here, this is also in the context of 1. So what this means right here is G prime of 1 times H of 1 plus H prime of 1 times G of 1. And as you can see, it gets real cumbersome and real kind of bulky and kind of muddled as we write everything out. So a lot of times when especially we're just thinking about context and formulas, it's okay to streamline it. We just want to make sure that when we're actually doing the math, which is what I did right here, I write everything out in its entirety. Okay? See if the next one's any different. What do we get? 6. And here's a table. All right, the table lists values for f and g and h of their derivatives f prime and h prime for x equals 3. All right, so this is a lot easier. They did the work for us. So I would say that this now implies that it would be the derivative of the first times the second plus the derivative of the second times the first. And then we just plug it in. And this, we're evaluating it at 3 here. And that's what these are outputs of. So f prime at 3 is 6 times h of our function at 3 is 0 plus h prime at 3 is 4 times f at 3 is 6. 6 times 0 is 0 plus 24. Answer 24. Rest of the problem should be similar.